Okay, so today's lesson is kind of an extension from last time. Today's lesson is about three special quadrilaterals, and more specifically, three very special parallelograms. Since all three of these are parallelograms, I will be referring a lot to these properties that we discussed on our last lesson. Just to review really quick, just to note a couple of things, we have opposite angles congruent in a parallelogram. Obviously, we have parallel lines on opposite sides. We also have opposite sides congruent to each other. And then if we draw the diagonals, we can also see that they actually bisect each other where they cross. So they cut each other into two equal parts. So all of those properties apply to the following. Okay, they apply to rhombuses, rectangles, and squares because they are all parallelograms. Okay, so let's get started with the first that I'll discuss today, which is a rhombus. Okay, mostly because I didn't want to bore you with a 30-minute video today. I figured I'd just write out my notes and you guys can pause the video at whatever time if you're taking notes at home. And that way I won't take up too much of your time today on this asynchronous day. Let's see. So 6-4, properties of rhombuses. This is actually our first shape, a rhombus. A rhombus. Okay, and a rhombus has a few special properties that it shares with parallelograms in general. First of all, the definition of a rhombus is a parallelogram with four congruent sides. So the first thing I'm going to draw on here is to emphasize the fact that it's a parallelogram. So we have opposite sides parallel. We have opposite sides parallel in my picture, so I'll mark that first. And then also, let's go ahead and mark the other important thing about parallelograms. So it is a parallelogram with the definition that it has to have four congruent sides. So all four of those sides are congruent to each other, not just the opposite ones. So it's kind of like a square without right angles. The diagonals are also perpendicular to each other. So if we draw those diagonals really quick, sorry for the blast off there that we did with the screen. But if I draw in these diagonals, okay, we can actually see that they are perpendicular. They meet at a right angle, so that's the second thing to note about the rhombus. Fun fact about the diagonals. The diagonals also bisect the vertex angles, meaning that these two angles are congruent. And let's see, if we call this A and we call this C, these are two opposite angles, which means that these two bisected angles here over at A are also congruent to those at C. And that goes for these two as well. I guess that would be B and D for this parallelogram. So they bisect those angles at the vertices, and they are perpendicular to each other. That's about it for a rhombus. We're going to look at rectangles next. Okay, so a rectangle is another parallelogram. It's kind of the flip of the coin of a rhombus. Instead of having four congruent sides, as most of you know, rectangles just have the opposite sides congruent. Instead of having four congruent sides, we actually have four congruent angles. And since it is a quadrilateral, if we take 360 divided by 4, we get 90 every time. So we get four right angles. Okay, so that's really the definition of a rectangle. It's a parallelogram with four right angles. That's really all there is to a rectangle. Something special about their diagonals as well. That's pretty much different from a rhombus. So this is unique to rectangles, not rhombuses. If we draw those diagonals, we actually make two congruent triangles here. And because of that, you can prove this to yourself as well. The diagonals actually are congruent. So if we call this A, B, C, and D, we could say that AC is congruent to BD. Okay, like I said, feel free to pause the video at any point to catch up on these notes. I know you don't need to hear me talking the entire time, so feel free to pause and take note. And finally, the parallelogram that we know the most about is the square. The square is kind of an amalgamation of a rhombus and a rectangle, just based on its definition. Let's see, just like the rhombus, it has four congruent sides, and just like the rectangle, it has four right angles. and we call it a square. It's just a very special circumstance where you kind of have like all the properties of a rectangle and a rhombus and a parallelogram combined. It does have, most famously, all congruent sides. We can draw those in, as well as my right angle markers. Since it shares all the same properties, we can actually then gain a lot of information about the diagonals. First of all, since it's a rectangle, I know that those diagonals are congruent. And since it is a rhombus, I know that those diagonals bisect those vertex angles. So each of these would be 45 degrees, each of those smaller angles there. It turns out that all these legs that meet in the middle of these diagonals are also congruent to each other. So we get a lot of congruent triangles. We get 4 congruent triangles out of this when we draw the diagonals. The reason why I'm calling it a rectangle rhombus hybrid will become apparent once you see the chart. So give me 1 second, I'm going to go pull up the chart. Okay, this chart is on Canvas, but I'm not going to go over these 2 branches of the quadrilateral family tree. I'm not going to go over these 2 branches until next time, so that's going to be on Thursday. These are trapezoids and kites. And I'll explain what the difference is between the 3 different branches of this chart. The one that we're focused on today is the set of all quadrilaterals that are parallelograms. So what's special about these is that they have 2 pairs of parallel sides. Okay, that's the most defining characteristic of a parallelogram. It's in the name. And this chart is going to be super useful for you to refer to. It also has opposite sides congruent. It's useful to have all these parts of the drawing in your chart so that way you can get as much information from this chart as possible. We also have opposite angles congruent. Once again, I am kind of going through this kind of fast, mostly because we've already talked about most of this. This is really just a summary and a way for you to condense all this information. Okay, in the family of quadrilaterals, okay, we can see that this is kind of like a chain. And the way the chain works is that everything below the line carries all of the properties from the one above it. So, for example, parallelograms have 4 sides because they're quadrilaterals. And, for example, rectangles are also parallelograms. You can follow the tree up like that. Speaking of rectangles, in fact, we only need to draw the right angles of a rectangle because how the tree is set up. We know that the opposite sides are congruent. We know that the opposite sides are parallel. We don't need to draw that because we already drew it in the parallelogram. So that's all I'll note about rectangles. I also want to note real quick that they have congruent diagonals. Okay, so that is specific to rectangles. So that's important to note. They do have congruent rectangles. Can't believe I said that. They also have, they do have congruent diagonals. So that is important to note about the rectangle. The rhombus, let's go ahead and put the defining feature of a rhombus on here, the 4 congruent sides. Once again, rectangles have the angles, rhombuses have the sides congruent. The special thing about the diagonals of a rhombus is that they are perpendicular. So I like to just draw the little perpendicular symbol on my chart. So that way I know that about the diagonals of a rhombus next time I look at this chart. And then finally we have the square. Since it holds all the properties, technically we don't have to draw this. But since the square is so special, I figured I'd do it justice. And like I said, the square has all of the properties above. So a square has perpendicular diagonals, just like a rhombus. The square has congruent diagonals, just like a rectangle. And it's also a parallelogram. So a square is technically both. It's technically both a rhombus and a rectangle. You could also call it a parallelogram and be correct. You can also call it a quadrilateral and be correct. So that's how the tree works. You kind of follow it upwards. We will finish this family tree next time. But for now, let's head back to the notes and do a couple of examples with my special parallelograms. Okay, example number 1. What are the measures of the numbered angles in rhombus ABCD? And the key part here is that it is a rhombus, which means that we got all 4 sides congruent. This is how I recommend you starting a problem. If it says it's a rhombus, then draw it like a rhombus. We need to label all the parts here. And specifically, since we're talking about angles, the most important property that I'm going to focus on for this question is the fact that my diagonals, so here's one diagonal I'll focus on real quick. The diagonals are actually going to bisect those vertex angles. So for example, these two angles will be the same as these two. And we also have these two angles at B being congruent to these two angles at D. And with that, we already get our first answer. Since both of these angles at B are 58 degrees, then I know that angle 2 is 58 degrees, and so is angle 3. And that's just from drawing on the rhombus. Okay, so all you have to do is draw, and you'll see what relationships pop out. We still need to get angle 1 and angle 4, so let's figure out how we can do that. Right now, I can't see much we can do with angle 4, but I do remember something about the diagonals of a rhombus. Okay, so the second fact about the diagonals of a rhombus is that the two diagonals are actually perpendicular to each other. So I like to draw a box, and this box basically just means all of these angles are 90 degrees, including angle 1. Okay, so they're perpendicular, so you get all these 90-degree angles in the middle. We can then figure out what angle 4 is by just considering this triangle here, this bottom triangle. Since we know that angle 3 is 58 degrees, and we know that angle 1 is 90 degrees, we can actually find out what angle 4 is by solving this equation. 90 plus 58 plus angle 4 is equal to 180. Okay, so if we plug that in, if we just call that x or something like that, I'm sure you guys could solve this. All you got to do is take 180 minus 90 minus 58, and you will get 32 for angle 4. 32 degrees. Okay, so I wouldn't even call it x. I would just call it angle 4 and solve that equation. 32. And now we have the answer to this problem. Just like always, if you'd rather watch this video in the background while you have the notes key up, that's fine by me. But these notes are on Canvas, and you're welcome to pause the video at any time to catch up. Let's do just 2 or 3 more. These aren't too complicated. You'll notice they're all very similar. Okay, in problem number 2, we instead this time have a rectangle. So if we go look at my chart, I can go look up all the properties about rectangles that I know. In rectangle RSBF, SF is 2x plus 15. Okay, so that's SF. And we also have RB is 5x minus 12. And it turns out that SF and RB, oops, I already messed up my color coding too. Turns out that SF and RB are both the diagonals of this rectangle. And since they're the diagonals of a rectangle, I know that they must be congruent. So we have those two are going to be congruent to each other. Since they are congruent, I know that they're going to have equal measure. Okay? Since they are congruent, I know they're going to have equal measure. So we can write my equation, 5x minus 12 is equal to 2x plus 15. Okay, and since this is simple algebra, I'll just run through this. Subtract a 2x on both sides to get all of your variables together. 3x minus 12 is equal to 15. We can then add 12 to both sides to get 3x equals 27. The last step would be to divide both sides by 3. If you divide 27 by 3, 27 divided by 3 is 9. So we get x. We are going to have to plug this in. And let's plug it into SF. So I'm going to plug this into 2x plus 15. So we get 2 times 9 plus 15. And just to save you the calculation, I'll just do it on my phone real quick. If you do 2 times 9, which is 18, plus 15, you get 33. Okay, so you just have to find x by setting those two equal to each other, and then plug it back in to figure out the entire length. Okay, let's do a few more. Okay, I want to apologize if you're looking at the notes key online. You'll notice that I'm kind of jumping around a little bit here. But we're going to do number 11 next. Okay, we're not going to do 13. In fact, I don't even think you guys have number 13. So let's do number 11. This is a rhombus, by the way. If you're looking at the notes, all of these example problems on the second page are rhombuses. So we already know a few things about the angles going on here. We have to find angles 1, 2, 3, and 4. If we start drawing all the properties that I know about a rhombus, I already can tell that angle 1 is going to be the same thing as angle 4 because we have those bisected vertex angles by that diagonal there. Okay, I also know that the two diagonals are going to meet at 90 degrees because they are perpendicular, which means that we actually know that angle 2 is 90 degrees and angle 3 has to be 90 degrees as well, just because we know that they're perpendicular. I'm starting to see how we could get angle 1 using this triangle here, and once we figure out what angle 1 is, we're going to know what angle 4 is. So let's pursue that method. Angle 1 plus 90 plus 52 is equal to 180. We can combine some stuff. 142. To figure out that angle 1 has to be 38. And that means angle 4 is going to be 38 degrees as well, because we already marked them as congruent. Okay, so we're using some triangle properties in the past to help us now. Okay, since the rest of the examples on the notes are pretty similar and we're already pretty long into this video, I'm going to end it here and just give you instructions for the rest of the day. Okay, just to end off this video, I want to give you a list of things that I expect from you today, especially since I still have to take attendance, even though this is an asynchronous day. So make sure, even if it wasn't the first thing you did, make sure you go ahead and do warm-up 6-4 on Canvas. That's how I'm taking attendance from that warm-up. Also, make sure you watch the video and take notes. Hopefully, you should be done doing that, unless you skip to the end. Number 3, find the link to the quizzes on Canvas. This is just to quiz you on quadrilateral properties, everything that you watched in this video. It's not too hard. It is 19 questions, but it'll go really fast. I had some students complete it in about 20 minutes in my third period. So give that a shot today. Also, if you're looking to get your grade up after the Topic 5 test, if that was bad for you, the Topic 5 retest is now open, and it will be open until you guys take the final exam. So make sure to check your grades, because I just entered them this weekend. Check your grades, and if you need to retest Topic 5, it is open until the final exam. I hope you guys have a great day. Sorry the video was a bit long. Enjoy your day at home. I will see you guys on Monday. Okay. Later. Goodbye. Okay, for real now, I'm leaving.